Hello dear students, welcome to the course of Engineering Thermodynamics. Myself Mihir Mistry, Assistant Professor from Mechanical Department of LG Institute of Engineering and Technology. So today we are going to continue our session on refrigeration cycles, and in particular we are going to discuss about actual vapor compression refrigeration cycle. So there are two aspects to discuss this particular phenomena. So as you can see on the screen, the very first aspect is with respect to pressure enthalpy diagram. So let us discuss that. So here you can see initially the normal refrigeration cycle is 1 dash, 2 dash, 3 dash, 4 dash and back to 1 dash. That is highlighted by the dotted lines. Okay, so now what will happen? That is the normal cycle. So in normal cycle you can observe that at the inlet of the compressor you have dry vapor. Okay, and at the outlet you have superheated vapor, right? In actual practice, the vapor is superheated at the inlet of the compressor. Okay, so why sir it is done? Because in order to make sure that there is no wet particle or moisture particle present in the refrigerant, and that will enter into the compressor, because you know that if compressor will come into the contact of wet particles, then that will damage the compressor or that will reduce the life of the compressor. Okay, so you cannot exactly enter the dry saturated vapor. Okay, so for safety side we will supply the superheated vapor at the inlet of the compressor. So you know that here you can appreciate that the compressor will compress the superheated vapor, and at the outlet of the compressor you will have superheated vapor also, shown by 2 point. Okay, obviously here one thing will occur, that is the compressor load will somewhat increase because the diverging nature of the isotropic lines. Okay, that you know. Now next is what? Now in the condenser section, as you can observe, initially the condensation was taking place from 2 dash to 3 dash. Now in the revised cycle, in actual practice, what happens? In actual practice, subcooling is done. As you can see over here, from 2 to 3. So 3 dash to 3, that is the subcooling done, right? So why subcooling is done? Subcooling is done because the reason is simple. See, from 3 dash to 4 dash, ideally when the normal cycle is there, from 3 dash to 4 dash, you have expansion device or throttling device. So what will happen? If you are supplying pure saturated liquid as the inlet to the throttling device, then what will happen? Your throttling device will come in contact with the wet vapor of the refrigerant. You can observe that from 3 dash, starting from the 3 dash, the dotted line is shown in the wet region. The whole dotted line 3 dash to 4 dash is shown in the wet region, right? So now due to that what will happen? Bubble formation will occur, and due to bubble formation, bubbles might block the way of the refrigerant in the expansion device, because you know that expansion device means what? There is a very small diameter capillary tube having long length. So what will happen? If more number of bubbles have generated, then that may block the way of the refrigerant. Okay, so in order to neglect that, in order to reduce that possibility, what we will do? We will subcool the liquid by some amount in the actual practice. So subcooling means what? I have already told you. Subcooling means you are decreasing the temperature from saturation temperature at given pressure. That is known as subcooling. So here you can see 3 dash to 3, that is known as subcooling. Remember, the constant pressure is maintained over here. Okay, so now this 3 to 4 throttling process. So due to that what will happen? Advantage or gain will be there. Due to that, you know, and you can refer that due to subcooling the refrigerating effect will increase. So that is the advantage. And another advantage is what? Chances of blocking of the refrigerant due to bubble formation will be reduced, right? So that is the advantage also. Okay, so because you can see over here, the 3 to 4 expansion or 3 to 4 throttling process, half throttling process is taking place in pure saturated liquid region and the other half is taking place in the wet vapor region, right? So you can easily visualize that. Okay, so that is the funda of actual vapor compression cycle on pressure enthalpy diagram. Now let us discuss another aspect. Another aspect is shown for the TS diagram. Okay, so in detail, the actual vapor compression refrigeration cycle can be plotted as shown in the TS diagram. Okay, for the reference, we will also refer the block diagram shown on the top side. Okay, so now what will happen? Simple, students. At the inlet of the compressor, you will have superheated vapor, you know that, right? But in real life practice, in the compressor itself, there will be irreversibility because it is not ideal. In real life or in real practice, compression process will be irreversible. It will not be reversible. So due to irreversibility, and what will happen? Heat transfer will also take place. What kind of heat transfer? There might be possibility that heat will transfer from refrigerant to the outside atmosphere in the compressor or from the outside atmosphere to the refrigerant in the compressor. Okay, so there might be heat transfer according to the temperature of the refrigerant and atmosphere. According to that temperature difference, heat transfer may also occur. Okay, so what will happen as a consecutive or as a result? Simple. See, if heat is transferred from the atmosphere to the refrigerant, then the entropy will increase. So that can be shown by 1 to 2 dash line, dotted line, right? So you can observe that entropy is increasing. The 1 to 2 dash line is going towards the outward side. So heat has transferred from the outside or ambient to the compressor refrigerant. Okay, in that case this will happen. And in another case, what will happen? If the refrigerant temperature is somewhat higher than atmospheric temperature, then the heat will transfer from refrigerant to the outside air. So in that case, the entropy of the refrigerant will decrease. That can be visualized using the process 1 to 2. You can see that is also highlighted by a dotted line. So entropy is decreasing. Observe. At one point you have some entropy, at particular point 2, corresponding to point 2, your entropy has reduced. Okay, now remember student, I have already told you that these are property diagrams. So irreversible processes are generally highlighted by or denoted by dotted lines. So that is why here 1 to 2 and 1 to 2 dash, these are the two possibilities in actual life or actual compressor. They are shown by dotted lines. Clear? So that is all for compressor. Now what will happen? Next is condenser section. So in condenser section, what will happen? It might happen in actual practice that at the inlet of the condenser, you have pressure of, let us say, 1 bar. But at the outlet of the condenser, you will have the pressure of 0.9 bar. Ideally, our aim is to maintain the constant pressure throughout the condenser. But due to irreversibilities, the condenser pressure will not remain same throughout its operation. So that is why what will happen? That is why you can observe over here that condenser pressure at the inlet is somewhat higher. You can see the blue line, inclined blue line in the superheated vapor region, right? So below that is showing, the topmost line is showing high pressure. Now what will happen? As soon as it will enter the condenser, due to irreversibility, the pressure might fall by some amount. So now you can see the condenser section in the latent heat region, the pressure line which is shown is having the low pressure line, right? So I hope you can understand this, right? So in condenser in real life, the pressure might not be remaining constant. Okay, so that is also another real life phenomena. Now from 4 to 5, what will happen? So 4 number is at the outlet of the condenser, and you can observe the block diagram that between the condenser and in the expansion valve, you have a piping. So that is connecting the condenser and the expansion device. So in this piping, what will happen? As soon as the liquid refrigerant will pass through this piping, it will decrease the pressure by some amount, right? So you can observe that effect in the TS diagram by process 4 to 5, right? The pressure is somewhat decreased. So that is advantages over here in practical life, because what will happen if the pressure is decreased, then after expansion the enthalpy of the vapor in the entering into the evaporator will be less. So if enthalpy is less, then it will consume more latent heat, and that will be advantageous. Okay, so now here from 5 to 6, that is known as expansion or throttling, right? So 5 to 6 throttling will take place. Now further what will happen between throttling device and the evaporator? One more piping system is there, so the pressure drop will occur due to the irreversibility, right? That can be visualized during the 6 to 7 process, right? Further, 7 to 8, what will happen? Evaporation will take place, right? And evaporation will take place, so that process can be visualized during 7 to 8. Okay, now from 8 to 1, you have another connecting system between the evaporator and the compressor. So what will happen? Simple. Due to the heat transfer from the outside atmosphere to the refrigerant, the temperature of the refrigerant inside the piping will increase by some amount, right? So due to that, what will happen? The load on the compressor will increase. So how this is possible? Think, students, if you are increasing the temperature, right, of the vapor, then its specific volume will increase. And if the specific volume has increased, then in order to compress the same vapor, you have to do more work. So the compressor load will increase. Okay, so that is how all this actual vapor compression refrigeration cycles process will take place. Okay, so today we are going to keep up to this point. Thank you.